Okay. So don't forget, you will be turning this in for credit. All right, amplitude, 1A, we already said it. What was the answer? 3. And be careful with part B. If you put this, bless you, if you put that on the test, is it wrong?
Yeah.
Yes, what do you need? Absolute value. And what did I tell you guys? If you missed it the first time, put a star, put a note to study that for the test. All right, cotangent and cosine. Are they both 2 pi over b? Which one's 2 pi over b? So this one is the 2 pi over b, and cotangent is pi over b. Be careful with that. What's the most common mistake kids make? They do them all as 2 pi over b, because that's the one we've used the most. We use it for sine, for cosine, cosecant, secant. We've used it more often. So they do 2 pi over b for everything. Did anybody do 2 pi over b for part A? It happens. And again, if you did it, put a star, put a note, a highlight, an arrow, something. Study this. Don't mess this up on the test. All right, so pi over 2/3 or pi over 7 pi? 7 pi. 2 pi over b. B is the coefficient of x. All right, so what does this reduce to? 1 over 7. All right, next one. 2 pi over b, 2 pi over 7 over 4 or over 8? Over 4, which reduces to pi over 2. So again, be careful. Make sure you don't get caught up in all the little simple tricks that kids tend to make. All right, which of the following is an asymptote for the function y equals tan 3x? You had a quiz question like this. Sketching, are you guys okay if we sketch it? It's the only way I've shown you how to do this type. All right, what do we know about the tangent graph first off? It splits at the origin, right down the middle on the origin. Okay, so let's do our period length. Period is 2 pi over 3 or pi over 3? And then what do we do with the pi over 3? Split it. What's a mistake kids make? They find pi over 3 and they say, oh, that's 60, that's the answer. Is pi over 3 one of our asymptotes? No, it's our period length, but it's not necessarily our asymptote. So what do we do with the pi over 3? Cut in half, so we get negative pi over 6. Thank you, going too fast. Negative pi over 6 and positive pi over 6. So here and here, do you agree with, regardless if it's a tangent or a cotangent, the asymptotes are at the start and the end, right? Doesn't matter if it's shifted. It doesn't matter if it's split at the origin. Tangent, cotangent, asymptotes are always the start and the end. Yes or no?
Yeah.
All right. So what's the answer here? 30. Bless you. All right. Do we need to sketch the whole thing? No. All it asks for is an asymptote. Yes.
So you would do something like that for a little graph that has tangent or something?
Just tangent. So I am going to finish graphing it just to get the practice. Middle is 0. What's pi over 6 plus 0? Pi over 6 cut in half. Pi over 12. What's 0 plus negative pi over 6 and then cut in half? And this is positive tangent. And remember, for me, that's the one I remember it's increasing, and everything else I just kind of flipped this one around. So I would do this. Amp is 1, negative 1, and it looks like that. So before I answer your question that you had, just really quick, back to the tangent. Tangent is the only one that splits. So you asked, would we always do this with tangent and cotangent? Would we do the same thing with cotangent? No. Cotangent is like sine and cosine. It starts at 0 and ends at your period unless there is a shift. Okay? Yes?
Will the middle point always be like 0?
For tangent, when you say 0, do you mean on the x-axis?
Yeah, like you know how you got your middle point right at the origin?
Okay.
Will that always be
At the origin, if you're asking specifically about the origin, that's only if it's a tangent without a shift. If it's a tangent graph and it did not shift, right, left, or up or down, there's no vertical or horizontal shift, yes, that middle will always be at the origin. But again, if there's a vertical shift or horizontal shift, then you're moving things around and it's no longer true. But standard tangent, does it matter the period length? Yes. All right, questions? We're good? Okay, number 4. What is the at what x value or values do the zeros occur in the first period for the function y equals sine x plus 5? Whoa, okay. I heard 2 answers. I heard never and none before we did any work. I'm going to stop and I'm going to pause, and those are correct answers. I want you to think how they got it. Like, how in the heck did they look at this without any work and get none? And then I want you to think, and then I'll give you guys time to talk and give me answers. All right, now I want you guys talking to each other, helping each other out. I gave you time to think. Now I want to give you time to talk. You got it? You didn't get it? You're talking to each other. Hello, Mrs. Torres. Yes, I do. She's been here. She's been just thinking, and I meant to text you this morning, and I didn't. Thank you for breakfast. Love you. Bye. Okay. We're ready? Okay. Volunteer, raise their hand and explain why. Was your hand up to explain this earlier? Okay.
Because it's the vertical shift, so it's not going to have real zeros because it's shifted plus 5. If you go between 6 and 4.
Okay, so it's because the vertical shift is 5 and your amp is 1, so you said you're going to go between 6 and 4, you're never going to reach 0. You'll have fake zeros, that's what you said, yes or no?
Yeah.
All right, so I'm going to, for you visual people, I'm going to sketch it out here. She said 1, 2, 3, 4, 5 is the fake axis, and if the amplitude is 1, it's going to oscillate between 6 and 4. So how many fake zeros does it have? 3 fake zeros, but are those real zeros? No. Whenever they're at, and they're not going to use the word fake zeros or real zeros. When they say where do the zeros occur, they're talking about the x-axis zeros. What's the most common wrong answer kids give me? These 3 right here. So what would that be? 2 pi, pi, and 0? So be careful. None, never. Anybody want to see it done algebraically, like solving? Because I told you guys you don't always have to graph. You can solve it by hand. We're good? Yes, no? All right. What is the value of the function y equals 5 sine pi over 8 parentheses x minus 2 at 6 radians? You can sketch this. You can plug in. For me, I like these. I think they're easier to plug in, but it's totally up to you. When they give you a radian or a degree, what do we plug it in for? X. Are you guys okay if we try plugging in first? Yeah. All right. Y equals 5 sine pi over 8 parentheses 6 minus 2. I'm going to have you clean that up. What's 6 minus 2, and then what is that times pi over 8, reduce it, blah, blah, blah. Go ahead. All right, so I end up with this. Y equals, I reduced the 4 and the 8. Did you guys do the same? And get pi over 2. What do I do first? Do I multiply 5 times pi over 2, or do I evaluate sine of pi over 2? Sine of pi over 2. So you know it, you have it memorized, you think in quadrantal. Pi over 2 is 90, that's 0, 1. All right. What is sine of pi over 2? 1. So 5 times 1 is 5. So that is letter B. Are we good? Does anybody want to see it graphically? Yes. Okay. All right. What is the amplitude? People wanted to see it graphed, so I'm just going to do a quick sketch. And because I'm running out of room this way and I have more room up here, I'm going to write the information up here. All right, what's the amplitude? 5. Period is 2 pi over 8. What do we get? 16. Again, if you're not sure, that was 2 pi divided by pi over 8. When you multiply by the reciprocal, the pi's reduce, and 2 times 8 is 16. Is there a vertical shift? Nope. Is there a horizontal shift? And you set this equal to 0, and what do you get? What is it? 2. All right. Because there is a shift, we have to adjust our start and our end. Our start is always our shift. So what is our start? 2. And how do we find our end? 2 plus 16, the period. And what do we get? 18. All right, so all of this is for this problem here. All right, so let's get this graph. Start at 2, end at 16. Okay. All right, what's 16 plus, let me write my amp in, sorry. What's 16 plus 2 cut in half? 9. That is supposed to be 18. Thank you. Who said it and didn't say it out loud? Yes? Is that you? No? All right. It should be 18. Does anybody see why it should not be 16? Yes, because it was 2 plus 16 is 18. And I meant to do it, and I did not, and I should have. Do a quick subtraction. What's 18 take away 2? 16. And is that the period length? Yes. All right. 18 plus 2 cut in half. 10? 10 plus 2 cut in half. 6, and 10 plus 18 cut in half. 14. All right, and it's asking at 6 radians, so right here is where we want to know what's going on with the graph. I'm going to go ahead and continue. This is sine, and it's positive. This is my start, so it's 0, max, 0, min, 0. At 6 radians, what is the value? 5. 6, 5 would be the ordered pair. So at 6, it is 5. So algebraically, graphically, your choice. Got it? Anybody like the graphic way better? Yes.
So you said when it's radians or whatever, you plug it into x. When do you plug it into y?
If it said, what is the radian value at blah, blah, blah. What is the radian value, or what is the degree value? Then you're looking for x and you plug in for y. Okay. Graph the following. Before I move on, any questions on 1 through 5? All right. Graph the following. Y equals 4 sine 2/5 x. What is the amp? 4. Period. Pi over b or 2 pi over b? 2 pi over 2/5. Now, on your test, I would expect to see some workspace around your graph. Okay, so what do we get? Multiply by the reciprocal. No one knows? Good. All right, so she said it would be 10 pi over 2, which would just be what? 5 pi. All right, is there any vertical shift or horizontal shift? No. All right, 5 pi. Now, you're probably thinking, this is so easy, why is she going over an easy one? I just want to review your points when they're not easy numbers to cut in half. So, cut in half using fractions or cut in half using decimals. Your choice, just do whatever's most comfortable for you. So if you write this as 5 over 2, you don't have to write down with me yet. And then you can write this one, what's 5 halves cut in half? 5 what? You then see if you can find a pattern, or make this a common denominator. Like, could I add these two and cut them in half without using a common denominator? No. So you don't use fractions, or you use fractions and you make sure you're careful with your common denominators, or you use decimals. So I'm going to start over. Which way would you like me to show, decimals or fractions? Decimals. All right, what's 5 cut in half as a decimal? 2.5, and you will have calculators. That one was easy anyway. 2.5 plus 0 cut in half. 1 point what? 1.25. And I'm going to put my pi's in there. All right, 2.5 plus 5 is 7.5 cut in half. 3.75 pi. All right, sine, and it's positive. Sine is the one that snakes around, or cups? Snakes around, so it starts at 0, maximum 0, minimum 0. Yes or no? So you have your hill and your valley. All right, yes, makes sense. So this part here is where kids tend to struggle on the key points, the middle and the quarter points. Make sure you're being careful whichever method you use. All right, next one. What is the amp? 1/2. Period. 2 pi, yes or no? Okay, so that's a pretty easy one. 2 pi, what's half of 2 pi? Pi, what's half of pi? Pi over 2. 2 plus 1 is 3. 3 cut in half is 3 pi over 2. Or you look for the pattern, 1 over 2, 2 over 2, 3 over 2, 4 over 2. And it says secant, but what graph do we think of in our head? Y equals negative 1/2 cosine x. Cup shape or snake shape? The cup shape does not start at 0, correct? It starts at a max or a min. Because it's negative, where would it start? Min. And what is my amp? 1/2. Negative 1/2. So minimum 0, maximum, minimum, 0, minimum 0, max 0, minimum. Couldn't get my words up. All right, the biggest mistake kids make is this. And then they stop and they move on to the next problem. Would we get it wrong if we stopped here? Yes. Now, some of you don't even sketch this piece, and you do not have to. You do not. I only did it to show you where kids mess up. They give me this graph, and then they move on. How many of you, and I've asked this before, how many of you don't even sketch this? You just kind of get the key points and then put your graph in. And that's perfectly fine. That might be safer for some. So I'm going to start putting my key points in. Where are my asymptotes? Okay, at the zeros, yes. And if there was a shift, it would be at your fake zeros, if there was a vertical shift. All right, now, is this the one that's going to have two complete U shapes or one full one and two half ones? And where's the full one going to occur? In the middle. And it goes towards your, always goes towards your asymptotes and always goes away from your x-axis or your fake axis. So this one's here is going to go up towards the red line or down towards the red line? Down. And this one here? Down. Bless you. And then you erase this middle stuff here. Or if you didn't graph it, you don't have to worry about this step. All right. Questions? Yes.
Do you have to erase it on the test?
Yes. Yeah. Yes.
How'd you get the half ones? How do you know like which direction to go?
These ones on the outsides here, you always go towards your asymptotes away from the x-axis. Okay, always go towards your asymptote. So somebody asked it in this class when we first did it, how do you know not to go this way? Because that's going away from your asymptotes. If you look at the U in here, do you see it goes the left towards the asymptote and the right towards the asymptote? Same thing here. Right towards the asymptote, but there's no other piece on this side. And this one is left towards the asymptote. Towards the asymptote, away from the x-axis. All right. Are we good? Okay. Back side. All right. Why do you think letter C is one of the most missed on the test? Two things going on here. Tangent, which is tricky because it does what? It cuts in half at the origin, and not only is it doing that, but it's also doing what? Shifting. So be careful. Amp is what? 1. Period. 2 pi over 3 or pi over 3? Okay, and what do we do with the pi over 3? So negative and positive pi over 6. Now this is the only special one where this would be my original start and this would be my original end, but I have to do what in both cases? Add the what? Add the shift. What is the shift here?
Negative, or just pi over 3.
Pi over 3. If it was negative, then I would add a negative pi over 3. But does everybody see why it's positive? X minus pi over 3 equals 0. Distribute the 3 or not. It's up to you. It's not necessary. Even extra work here because you're going to have to do what here? Common denominator. I'm going to let you guys do that. Do you agree pi over 3 is the same as 2 pi over 6? Pi over 3, 2 pi over 6. Do that now and add them together and see what your new start and new end would be. All right, what do we have? First one is what? Pi over 6. And this one here? 3 pi over 6? Yes or no? Why do I not reduce the 3 pi over 6? Because I want them to what? I want them to have a common denominator. All right. Add and cut in half. What's 3 pi over 6 plus 1 pi over 6? And you just have to cut the top in half. You cut in half. What do you get? 2 pi over 6. 2 plus 1 is 3. And if you don't like the decimal, then you do 3 over 6 times a half is what? 3 pi over 12. Or you do what? 1.5 pi over 6. Your choice. All right. 3 plus 2 is 5 pi over 6. Cut in half is 5 pi over 12. For those of you using decimals, you'd have what? 2.5 pi over 6. Your choice. All right. It doesn't matter whether it's tangent or cotangent. Your start and your end are always your asymptotes. Okay, and the middle, whether it's tangent or cotangent, is always 0. And since it's positive tangent, it's doing this, increasing. Yes? So this one is a 1, this one is a -1, and it's going like that. Questions? We're good? All right, letter D. Another most missed on the test, and I'll explain why as we go. Can anybody tell me what the amp is? 1. Okay, what is the period? 2 pi over 4, he's saying is 8. Do you guys all agree with him? All right, is there a vertical shift? Vertical shift is up 1. So should I change these amp markings? I should. I'm going to go up 1. And if I go up 1 for my fake axis, what is my new max and min going to be? 2 and 0. Is it going to oscillate between 2 and 0? Yes. All right. Is there a horizontal shift? Set this equal to 0. What do you get? -1. Because there is a horizontal shift, do I have to adjust my start and end? Start is -1. End is -1 plus what? -1 plus 8. So what is my end? 7. All right. Questions before I move on? Okay. -1, 7. And I just put little tiny tick marks in there so I can figure out where things are. All right. Cut negative, not cut in half yet. Add -1 plus 7. What do we get? 6. Cut in half. 3. 1, 2, 3 is my middle. Do you guys see how I did that?
Yeah.
Beginning plus end. 1, 2, 3, 4, 5, 6. Let me do a little better in spacing out. All right, so this is the middle. And then I'm going to add these two. What's -1 plus 3? 2 cut in half. 1 is another key point. I'm going to erase that as a dot and put a marking there. And then what's 3 plus 7? 10 cut in half. All right. Okay, so what are our 5 key points? -1, 1, 3, 5, 7. Do you see that? What's not a key point that we're used to being a key point? 0. And I think that's where kids fumble up because they try to force 0 to be in there. It's not, and it's just the way the problem works out. This is cosine, and cosine does what? Cups or snakes? Cups. I'm going to erase this just so I have room. So at my start, I start at the maximum because it is positive. Do you see that? My next key point, which is not 0, it's 1, is a fake 0. My next key point is a minimum. Next key point is a fake 0. And my last key point is a maximum. So I'm still doing max, 0, min, 0, max. But what did not come into play? The 0 here. And I think that's where people get stuck because they want it to be a key point, and how do I get it in there? Is it okay if 0 is not a key point?
Yeah.
Yes, it is. It still works out the same. There are my 5 key points. 1, 2, 3, 4, 5. How many zeros? 1. How many fake zeros? 2. But when they ask how many zeros, they're talking about the real ones. Where does it occur? 3. Yes?
How did you get the vertical shift again?
The vertical shift's right here at the end, the +1. you set this equal to 0 to get the -1. All right? All right, write the equation. We are running out of time, so shall we do one of these?
Do the second one.
The second one. All right, what can you tell about this one here? It's cosine.
There's a vertical shift.
There's a vertical shift. How do we find it? We find the midpoint here. You guys remember how to find midpoint? You add these and cut them in half. What's 3 plus -7? Sorry. -4 cut in half. So -2. So that is the vertical shift. All right. What is the amp? Can you guys tell what the amp is? -2 to -7 or -2 to 3. It's 5. Or you do what? You find the distance between 3 and -7 and cut it in half. The distance 10 and 10 cut in half is 5. Your choice in how you find the amp. All right, I'm going to go ahead and start. Y equals positive or negative cosine? Positive 5 cosine. I usually save my B for the end. You can find it first. It does not matter. But keep it on the outside. Remember that. X and then your horizontal shift. Is there a horizontal shift here?
No. Or
Yes. If people, well, it starts at 0, no, it's ending at 0. If it starts at 0 and ends at your period length to the right, there's no horizontal shift. But this started at -7 and ended at 0. So what's the horizontal shift? -7. What goes in here? +7. Do you guys see that? All right. And on the outside, what do I put for the vertical shift? -2. All right. What's the last thing to find? B. And what do we do? 2 pi over B equals the period length. And how do you find the period length? Right minus left. What's 0 minus -7? 7, right? The length here between 0 and -7 is 7, yes or no? All right, so then cross multiply, 2 pi equals 7b. Divide by the 7. Do you have it? What do we get? 2 pi over 7. All right, I'm going to give you the answer here just so that I would suggest that you go back and do it on your own later and then check that you got it right. So write it down, cover it when you get home, try it on your own and see if you can come up with that same answer. All right, I'm going to move on to number 8. Questions before I do. Really quick, how do you find your period length here? 5 pi over 6, take away pi over 6. All right. Arc sine, √3 over 2. Quick reminder, where is arc sine defined? Top half or right half? Right half, because sine is positive, positive in the top 2. You don't want to be positive, positive. All right, it's positive. Which quadrant are you in? You're in quadrant 1. You'll have your unit circles. I still have them, but I'm just going to do the hand trick for now. When is sine √3 over 2? 60 degrees. And since I'm in quadrant 1, that's your answer. 60 degrees or pi over 3, your choice. And that's it. Can I move on? No, you will not have to list.
Is it like multiple choice, or do we write it?
Like all tests, there's some multiple choice, there's some not. Sometimes there's very few multiple choice. It's not like the math, the Common Core classes where there were always the first 15 multiple choice. It's not like that anymore. All right, arctan. Do you guys remember where arctan was, or inverse tan was defined? Right half. It's negative, so it's in quadrant 4. Yes. which means it's negative 30, negative 60, negative 45. Do you guys remember that? This we're not used to. Do you guys remember what this is the same as?
1 over root 3.
Negative 1 over root 3. Is that the same as negative root 3 over 3? All right, when is tangent? Tangent is your y over x. When is it 1 over root 3? 30 degrees. So 30 degrees. And I'm just going to write 30 degrees this time. But if you wanted to, you can write what? Pi over... Thank you. Thank you. Or negative pi over 6. Now, Leonard, was that you that said it? That said negative 30. Okay, why? Did you guys catch it? Why is it negative? Fourth quadrant. And inverse is negative 90 to 90. So if you're in the fourth quadrant, it's a negative angle. All right. I'm going to cover this. What is tan of 45? We should have that one memorized. 1, right? It sine and cosine's 1 over root 2, but when you put that over it itself, it's 1. Yes or no? And then you're doing inverse sine. So now we're going to end up with an angle answer like we did up here. Sine is the top half or the right half. So there's these 3 quadrantals, 0, negative 1, 0, 1, and 1, 0. When is sine 1? 90 degrees, or pi over 2, your choice. All right, this one, again, because the inverse is on the outside, we will end up with an angle answer, or non-angle answer. All right. It's going to be like this one, sorry, where we do have an angle answer. Okay, what is sine of 120? What's your reference angle? 60. What's sine of 60? Root 3 over 2. Where is 120? What quadrant? 2, and sine positive or negative? Positive. All right. So you have to keep track of all that stuff. I'm going to write it this way. That is the same thing. All right. I don't know why I did so many signs. Where's inverse sine defined? Top half or right half? Right half. Positive is going to be in which quadrant? And when is sine root 3 over 2? 60 degrees. You guys are awesome. All right. Last one. Is this have anything to do with any of our unit circle business? When it does not, what do you have to do? Pythagorean's theorem. You have to draw it and use Pythagorean's theorem to come up with the third side. Okay, finally I have an arc cos. Where's arc cos defined? Top half. It's negative, so which quadrant will I be in? Does it matter? Does it make a difference where you draw it? Yes, it does. Okay, cosine is opposite over hypotenuse or adjacent over hypotenuse? So I would label this 3 and this root 58, and where do I put the negative? On the 3, for 2 reasons. One, because it's going negative, and you never put it on the hypotenuse. All right, so you would do negative 3 squared plus b squared equals root 58 squared. I'm running out of time, so if any of you have it, or I can give it to you. 7, good job, you guys are awesome. Positive 7 or negative 7? Positive. Do you have to keep track of that stuff? Yes, you do. All right, so then you're doing sine of this picture. What is sine of this picture? 7 over root 58. Make sense?